Here we show you TouchPass, an on-touch user authentication scheme on smartphones leveraging vibrations. Nowadays, we touch our smartphone anytime, anywhere, to send messages, check emails, shop online, etc., and with various touching moods. Therefore, the heavy usage of smartphones and the very frequent touching behaviors call for a behavior irrelevant on-touch user authentication scheme. That is, for a legitimate user with arbitrary finger touching on smartphone, he or she could be authenticated. And for a spoofer, no matter how he or she touches the smartphone, the authentication fails. Considering most operations on smartphone requires finger touching, we would like to explore the physical characters of fingers to identify different users. And everyone does have unique fingers, as they can be different in geometry, bones, muscles, and even conductivity. To build a user authentication system from that, we first need to extract features from the fingers, and then train a behavioral irrelevant classifier with the features. We'll first take a look at feature extraction. To capture the physical characters of human fingers, we utilize active vibration signals that can be generated by smartphones. Typically, most smartphones could generate single-frequency vibration signals, and it can be divided into two states. The transient state when the vibration signal starts, and the steady state when the vibration signal reaches balance. For transient state, since the vibration signal is highly dynamic, we would like to capture the changes in signal amplitude and frequency as much as possible. So we apply a continuous wavelet transformation to the vibration signals and collect the stripes in the time-frequency plot as the features. For steady state, since the vibration signal reaches a balance, the differences among users in frequency spectrum are not obvious. Therefore, we utilize the substrom of vibration signals to capture and amplify the small dynamics in different frequency bands, which embeds the characters for different users. Then we enter the step of behavior irrelevant classifier training. For the features we extracted from vibration signals, it contains both physical characters and behavioral biometrics. And we would like to emphasize the physical part and ignore the behavioral part. To do so, we utilize a special neural network model, Siamese network. As the name suggests, Siamese network always takes a pair of samples as input to train the parameters. So the selection of training sample pairs is important. For samples of the same user, we choose samples with different touching behaviors as training pairs, while for samples from different users, we choose samples with similar touching behaviors as training pairs. With the selected training sample pairs as the input of Siamese network, we then could train the behavior relevant classifiers for user authentication. To evaluate our system, we use 3 different types of smartphones, 75 volunteers divided into 3 groups, to conduct experiments in 3 different environments: lab, bar, and bars, with different level of extra vibrations. Here we show the overall authentication results in these environments. The accuracy are good for all environments, and the lab has the best performance, while the bars has some accuracy degrees because of extra vibrations. And we further show the performance of system under 2 typical attacks, mimic attack, and replay attack. And we can see our system get under 2% false positive rate for each case. Thank you for watching. We will take questions later.